Hi guys, in this video we will be learning about the concept of functions of one variable. So what exactly is a function? When you have a one variable function, so that basically means that you have two variables being involved and one variable is dependent or a function of another. So one variable is a function of another, is a function of another if the one variable is basically dependent on the second. The first variable is dependent on the second. So if first variable is dependent on the second. So is this dependence relation which is called a function, but that doesn't mean that every relation is a function. But let's take example and try to understand what could be called a function. Suppose you talk about circumference of a circle. So suppose we talk about circumference of a circle. And we know that circumference of a circle is 2 pi r. 2 pi r, where pi is a fixed value. Pi, we all know it's 3.14, so on and so forth. It's non-ending, repetitive, it's a decimal that never ends. So, can you see that there is clearly a relation between circumference and radius? R stands for the radius. And you keep on changing the radius, you will get different circumferences. That would be telling you about different circles, right? So it's basically, we can say that circumference is a function of radius. Circumference C is a function of radius R. We can say that. So it's this relationship. It's a relationship between variables, okay, between two variables. That's why I said that when you're talking about a function of one variable, that means two variables are involved, okay. So it's this relationship between two variables, okay. But now this relationship or a rule, you can also call this a rule. This rule which you have between these two variables, it will have this relationship rule will have one characteristic. And what is that? It will have one characteristic, and that is that a definite rule relates each value of one variable to a definite value of another variable. Can you see? This is very much true. How? See, the different values of r, that is one variable. The different values of r will give you a definite value of r, will give you a definite value of the circumference, right? So different values will give you different values of the circumference, right? So that's what is a definite rule. So let me now define formally what a function of one variable is. So function of one real variable. So we'll be talking about real functions here. We'll be talking about functions of real variable. So a function of a real variable x with domain say D. Now I'm going to explain to you what this domain actually means. X is with the domain D, that means your input set, okay, is a rule that assigns a unique real number to each number x in D. So to each x in D. This rule is assigning a unique real number. Okay, so there are two important parts. If you can see to this definition, there are two important parts that the rule is assigning to each number x in D. It is assigning a unique real number in whichever set. Okay, a unique real number. Okay, which is your output basically. So, every rule, now just by writing the rule, just by writing the word rule, you don't get to know what the function is. So every rule can be, can be an algebraic expression. Every rule can be maybe not an algebraic expression, but could be depicted graphically. A rule could be depicted like a table. So every rule, just remember that every rule with its properties, or with these properties, with this property, in fact, what is the property? The property that to each x in the domain, the rule will be giving a unique output. Okay, this is called a function. So it will be very important for you, when you are doing mathematical economics and when you are doing maths per se. It's very important for you to understand what relationship is a function, a valid function, what relationship is not. So you need to know what is a function and you need to know what is not a function. So I'll be talking about all that, in the further videos. It's denoted in general with F, G, H, it could be capital letters also. This is how it is depicted. And when you write fx, it basically means the value of the function, at input x. Okay, so when we write fx, f is the relation or f is the function, and fx means the value of the function at this particular input value x. Okay. Now this x that we are looking into, this x that we are taking, this is your independent variable. It's an independent variable which is giving you, say, your y. So most of the times, this is how we depict. We write a function f of x equal to, say, y. So that means y is the value that this function is attaining at the input x. That's what it means. So x is the independent value which is deriving a value y for you. So that means y is dependent. With this depiction, you can say that y is dependent on x. In economics per se, we use another word for it. So the vocabulary goes like this. So x is called exogenous. It's also called argument of f. Okay, exogenous variable, and y is endogenous variable, which is something that you will derive. And exogenous is somehow given from outside, in general, outside the model. Okay, or independent. That's what it means essentially. So this is what is the definition of a function. This is what function actually means. So what does this actually mean? It means that if I write down function from A to B, so from A to B, if I write down f is from A to B, that means, is a function. If I say that this is a function, that's only happening because, this, in other words, actually, mathematically speaking, it means that for each x belonging to A, because A is your input set. When you write f A to B, that means A is your input set and B is the set where you will find your output, okay? So, for each x belonging to A, there is a unique y belonging to B such that the relation fx equal to y wholes, such that f of x is equal to this particular value y, and this is happening for each x in the input set. So you cannot have any idle element in the input set, okay? This is how you define a function. Now I'm also going to in brief talk about functional notation. Functional notations. So we in general denote a function like a formula or an algebraic expression. So we denote functions by a formula, and a formula is valid, and a formula is valid when it is true for any input that you take. It is when it is defined for all inputs, okay, when it is defined for all inputs. So basically it means, let me just give you an example. So an example could be perhaps having a formula like squaring a number. So suppose assign to any number the second power, or squaring any number, second power. So this means that the function would be, if x is my input, then f of x, I'm saying give it power 2 or square it. So it's going to be x square. So x square will be, the function. And you can see that this should be valid for all inputs. So you can see that, okay, 0 square is 0. So that's fine. It's a real number that you get. That's f of 0. Similarly, f of 1 will be 1 square. So it's going to be 1. F of 2 will be 8, and so on and so forth. Similarly, f of x is x square, then f of x plus 1 will be x plus 1 whole square. So your input is x plus 1. Your input is x plus 1, okay? So it's going to be different from x square plus 1. Your input is x plus 1, and this will be x square plus 2x plus 1, okay? So that's what is a functional notation to any function. So you have a valid function. Maybe you can give it an algebraic expression like this, and this is what it should be valid. The algebraic expression should be valid for all the inputs. In fact, in the next step, we will try to find out domain for any given function, and that is where we will figure out that if a formula has been provided to you, then it should be valid for all inputs. So we will only take those inputs in our domain set, which is the input set, which gives us a valid formula, which gives us an output, okay? Now I'm going to just give you here a brief economic application of functions. So, economic application, wherein I'll just talk about one small concept actually. Total cost of producing X units of a product say is given by a function of x, so cost will be associated to producing x units. So C of x, it's 20 times x into root x plus 100. 20 times x into root x plus 100. So it's a function. And what I want you to find out here, what we wish to find out here is to find the cost of producing 25 units and respectively then q units. And then I also want you to find out, find the marginal cost. So I just want to talk about this concept of marginal cost here. Marginal cost is nothing but the incremental cost. Marginal cost is nothing but the incremental cost. So it essentially means what is the increase? In other words, I want us to find out what is the increase in cost from producing one additional unit. So everything comes from the formula of the cost function that we have. We can call this cost function. See, because if you're producing, you will never produce negative units, right? So your input is only positive, and clearly c of x is a valid function because for every input in the domain set, domain is your input set, and clearly in this case it will be r plus. Now what is r plus? That means we are only taking x greater than or equal to 0 because I have square root of x here. So this is very obvious that I cannot take negative. Otherwise also I'm producing x units that I'm producing. I will not produce negative. So my assumption will be that I'm producing either 0 or more than 0 number of units. So x is greater than or equal to 0, and this is a valid function. It's not a problem. Now we need to find out the cost of producing 25. So we have a relation already provided in terms of cost function. So cost of producing 25 units will be simply 20 into 25 into square root of 25 plus 100. So that means it's 20 into 25 into 5 plus 100, which I suppose when you multiply, I think you will get 2500 plus 100, that is 2600. 2500 plus 100, that is 2600. Similarly, if in case I want to find out for quantity q units, what is the cost for quantity q units? So I just have to substitute in place of q, in place of x, I have to substitute q, right? That's what this relation basically means. And now I'm interested in figuring out the incremental cost. So incremental cost will be if I am incurring certain amount for say 25 units, then I'll be incurring certain amount for 26 units. So just for one additional unit, how much more cost is required? Or in a generalized case would be if I am spending 20 times q into root q plus 100 for q units, I would be spending for q plus 1 units 20 into q plus 1 into square root of q plus 1 plus 100. The incremental cost clearly will be cq plus 1, the cost of q plus 1 minus the cost of q. So that's going to be 100 would cancel out, and it's going to be 20 times q plus 1 square root of q plus 1 minus q times square root of q. This is what will be your incremental cost. Incremental cost essentially is the marginal cost.